All right, let's do more problems. That's exactly what you want. More radius of convergence and interval of convergence. We're looking at, again, radius of convergence, interval of convergence. Here we go. Now, I'm looking at this thing. Let's start off. You have a k factorial times x to the k. Do you think, screw the power series stuff. Do you think when doing any of your tests, this is going to converge? You think that limit is going to go to frickin' 0? Get the frick up out of here with that. We have an x to the k, and it's not being divided by anything. But we're like, all right, let's do this thing. So we're going to need to either use our ratio or root. Typically, we're going to use ratio. Typically. Especially since we have a factorial, we're like, let's use ratio. Let's go find out what our little r is to see if it converges. It won't. I'm telling you right now. There's no even need to do work here. Look at that thing. I'm like, there's no way in hell that's converging. There's not even a freaking denominator, which means the thing's just going to blow up. I mean, unless that x value is really, really small or something. I don't know. So we're like, okay, so it's the limit is k goes to infinity of that a sub k plus 1 over your a sub k with the absolute values in there. So we're like, all right, oh, look, I remember to write my limit this time. Go me. So I got k plus 1 factorial times x to the k plus 1 all over k factorial times x to the k. There's not much work to do here, is there? All right, we're going to have our, oops, yeah, I wrote my limit again. Good job. 1 times 2 times 3 times dot, 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 k times k plus 1 times x to the k times x, right? X to the k plus 1, x to the k times x. Then we look down below and we have 1 times 2 times 3 times dot, 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 k, but we don't have a k plus 1, and then we have x to the k. Thus, all the numbers up to k go away. We lose our x sub k. Oh, I forgot it again. Absolute value, absolute value. I'm so bad with those. So it looks like we have the limit is k, not x, goes to infinity. And what do we have? We have k plus 1 up top. Those are all positive, so we need an absolute value times the absolute value of x. So we have the absolute value of x. We rip it out. Oops, why am I writing an equal sign? Times the limit is k goes to infinity of k plus 1. Dude, that goes to infinity. Has to go to infinity. Since it goes to infinity, that means it does not converge for frickin' anything. The series diverges everywhere. So there's only a single point. There's not even an interval of convergence. The only place it converges is at x equals 0, the center. We're saying if you only choose that number, we're good. Only when x equals 0, which means the radius of convergence is nothing. It's nothing. There's no interval. It's just the point x equals 0, and our radius of convergence is 0. So if you choose any value larger than 0, it's not going to work. Any value smaller than 0, not going to work. So it's kind of opposites. See how you get your little r is infinity, and that means our radius of convergence is 0. If our little r was 0, like the first example we did, we know that our radius of convergence is infinity. They're backwards. They are backwards. So let's do a second problem. And this one's going to have where one of the endpoints is going to work and the other one's not going to work. We didn't have to check endpoints there, that last one. So we're looking at this and going, do I want to do a root test? I mean, we could. We could, but I don't know. Ratio tends to work so much more. So I want to mess with that. Let's go find our little r. Now remember, if our little r is 0, we'll converge everywhere. If it's infinity, we're not going to converge at all, except at that one single solitary point, which would be at 2. Our center is 2. You see our center? It's right there. It's 2. X minus our A. Our A is 2. That's where we're centered around. But for this one, we're actually going to get it to go to a value. We're actually going to have it be a value. All right. So what do we do? How do we do this? Oh, I know what to do. I know what to do. We're going to take the limit as k goes to infinity of our a sub k plus 1 over our a sub k, not writing it again. So we get x minus 2 to the k plus 1 all over the square root of k plus 1 divided by x minus 2 to the k over the square root of k. Cool. It's going to come down here. And then we'll just start writing it. This is the absolute value of x minus 2 to the k times x minus 2. That's just the top. All over the square root of k plus 1. Now we will flip and invert the denominators. We get the square root of k, and we get x minus 2 to the k. The x minus 2 to the k's go away. And now, since the x minus 2 has nothing to do with any of this, I want to rip this out. The absolute value of x minus 2, I want to take that piece out, times the limit is x. Stop writing. X is k. It's k. Of the square root of k over the square root of k plus 1. But I don't want to write them both with the square root on top and bottom like that. I'd rather just do one of these. Big old square root. Now where does that go? Where's that go? Come on, dude. You don't need extra work. This is 1. Look at the limit inside. Leading coefficient 1. Leading coefficient 1. What's the square root of 1? 1. So we just found out that we have the absolute value of x minus 2 is equal to our r. And you're like, what? What? Oh! But when something converges absolutely and therefore converges, it's for all x such that the r is less than 1. Do you remember that? The r needed to be less than 1. This is from the ratio test. Remember that? When this thing converged, it only worked when that r was less than 1. So we have to say, all right, cool. This is less than 1. So what's our radius of convergence? What's our radius of convergence? It's freaking 1. It's 1. Now, if we would have ended up here and there would have been a 5 down below, our radius of convergence would have been 5. Ugh, did you catch everything from the previous sections? Because if not, we're kind of hosed. Now we need to find our interval of convergence. So we have x minus 2's absolute value is less than 1. So this is the same thing as take off the absolute values, trap it between -1 and +1, add your 2 to all three, I guess, sides for lack of a better word, and we find out x is trapped between 1 and 3. So our interval of convergence is going to be between 1 and 3. But I don't know whether these are parentheses or whether these are brackets. We have to check, which means we need to take our frickin' endpoint. So I'm going to start it off. I'm going to write it like this. And if we find out something happens cool, we'll add in a bracket. So we're going to take these values of x and plug them back in. So we're going to check it out. We're going to go the sum from k is equal to 1 up to infinity of something minus 2 raised to the power of k all over the square root of k, and now we're going to pop in that 1. There we go. I think we're good. So what is this? Let's zoom in. And again, this is for when x is equal to 1, and then we're going to do it again for when x is equal to 3. So what is this? This is the sum from k equals 1 up to infinity of -1 to the k all over the square root of k. Does that converge? Does that diverge? What do you think? Oh, there's a -1 in there. So now we have to remember our other series test. It's called the alternate. Oh, please don't tell me it's broken. Sweet. The alternating series test. You see that -1 to the k? It's telling you. So we have a couple of rules. Does 1 over the square root of k, remember ignoring the negative, as that gets bigger, does that go towards 0? Of course it does. Of course it does. It's going towards 0. It's also decreasing in magnitude. It's always going to get smaller. So, boom, that works. That converged. This converged by AST. This converges. Therefore, x equals 1 works. is in the interval. So we go back down to it. We're like, whoa, whoa, whoa. 2 brothers is just that? No. We'll take a bracket. Now let's go look at 3. Let's see what happens there. So we have the sum of k is equal to 1 to infinity of something minus 2 to the k all over the square root of k. And we're like, plug in 3. So now we get to this point. K is equal to 1 over infinity of 1 to the k all over k to the 1/2 power. I wrote it differently. Do we need the k on the 1? Absolutely not. Well, this diverges by p-series, right? The power on the k is less than 1. So that, well, yeah, it's less than 1, so it diverges. Therefore, we won't use x equals 3. That doesn't work. So our interval of convergence turned out to be include 1 all the way up to 3, but don't include 3. And our radius of convergence is equal to 1. This is our big game. This is the sort of thing you would be tested on, where I could give you something and just go like, hey, bro, give me the interval of convergence and the radius of convergence. There they be. Also not confusing big R and little r. I know they're the same letter. The smaller the little r, the bigger the big R, and vice versa. Check your endpoints. Use all the tests we learned before, and you'll be good. All right. See ya.